Hi guys, today we're going to be looking at fractions. So our aims and objective for today's session are we're going to be looking at what are fractions, okay, how do we write them, what are equivalent fractions and how we work that out. We're going to be looking at the key terminology for fractions. We'll be looking at working out fractions of amounts, and then to understand how to add and subtract fractions, including mixed and improper as well. So first off, what are fractions? So fractions show parts of things. If something is divided up into equal parts, you can show it as a fraction. There are two bits to every fraction. Okay, so we've got the top number and the bottom number. The bottom number is the denominator. This shows how many parts it is split up into in total. So the bottom number is how many parts it's split up into. The top number is the numerator. Okay, this is how many parts you have. So for example, if you've got a pizza and you've cut it into 5 slices and you've ate 2 slices, that would be 2/5. Okay, so we look at that in that instance. So the top number is the numerator, the bottom is the denominator. So if you get 7 out of 10 in a test, you can write it just like that, 7 over 10. So this is the fraction. You've scored 7 marks out of 10. 10 being the total, 7 is what you're working with. Okay, if there are 15 people in the office, 8 of them are female, okay, 8 over 15. All fractions, if you add up all the parts, should add up to the denominator, which in this instance would mean that if there are 8 out of 15 female, then there should be the rest of the fraction left would be 7 over 15. Okay, so the rest would be, so we would work it out as 15 over 15. That's the whole. All fractions add up to a whole. Okay, so in this instance, 10 over 10 would be the whole. So take away the 8 over 15. We only take away the top numbers. We leave 7 over 15. Okay, again, fractions, so parts. These are all different fractions. So the cake is split into 3. So the bottom number, the denominator, would be 3. One piece of cake, if you ate one piece of cake, would be on the top. So it would be 1 over 3, which is also known as a third. If it's split into 6, again, the denominator would be 6. And the top number would be however many pieces of cake that you ate. And the same with 9. So the bottom number would end up being 9 as well. So that's how we would write it. Okay, same here. So if you split into 3 and ate 2 slices, the bottom number would still be 3. The top number would be 2. Okay, the same with these ones as well. So, as we've mentioned, fractions represent part of a whole number. Fractions, decimals and percentages are actually just different ways of showing the same thing. So if you get 7 out of 10 in a test, you can write your score as 7/10. Okay, but you can also write it as a decimal. The way we do that is we do the top number divided by the bottom. So if we look, top number over the bottom number, there's the division symbol. Okay, that reminds us that it's division. This line is a division symbol. So 7 divided by 10. If we put that into a calculator, it would come out at 0.7. So 7 over 10 is equivalent, is the same as 0.7. And then we can get it as a percentage. If we want it as a percentage, we would do times by 100, which would get 7 over 10 equals 70 over 100, which equals 70%. Okay, so 70% would be the percentage. You just multiply the decimal by 100 and you get 70%. To get it back to the fraction that we had in the first place, okay, we would put this over 100, so 70 over 100, we would simplify that down by dividing the top and bottom by the same number, and we'd get to 7 over 10. But we'll come on to simplifying in a moment. So again, 8 over 15, if we did top divided by bottom, we'd end up with 0.53333, and as a percentage, times it by 100, we would get 53%. Okay, so fraction to a decimal is top divided by the bottom number, numerator divided by denominator, which we've done here. And to get from here to here, we multiply by 100. And then to get it back to where we started, we do 53 over 100 and simplify it down. We may not in this instance get back to 8 over 15 because we've had to round, okay, because this would be an infinite number. Okay, so if you want to pause and just have a go at these questions, okay, so pause it now and in a second I'll put the answers on the screen for you. Okay, so write these fractions as numbers. 1/3, so 1 over 3. 2/5, 2 over 5. 3/8 would be 3 over 8. 5/12 would be 5 over 12. And then write these fractions as words. So this would be 1/2, 2/3, 3/4, 3/5, 5/8, and 7/9. Nice and easy. Okay, and then what fraction is shaded? So 1 out of 4 is shaded. 1 out of 1, 2, 3, 4, 5 is shaded. 1 out of 9 is shaded. 1, 2, 3, 4, 5 out of 6 is shaded. 2 out of 3 is shaded. And 5 out of 8 is shaded. And then the last one would be 1, 2, 3, 4 out of 7 is shaded. 1, 2, 3, 4, 5, 6, 7 out of 12 is shaded. And 1, 2, 3, 4 out of 9 is shaded. Okay, so that's fractions, nice and straightforward. Okay, equivalent fractions. So equivalent fractions have the same value even though they look different. So these fractions are really the same. 1/2 is the same as 2/4, is the same as 4/8. Why they're the same? Okay, because when you multiply or divide top and bottom of the same number, the fraction keeps its value. So when I always think about this, I think about a pizza. So excuse my really bad drawing. So we've got a pizza, we cut it in half, and I have 1/2. I've had that amount. Another pizza, I cut it into quarters. I have 2/4. I've had the same amount. And the last one, I cut the pizza into 8ths. And I have 4/8. I've had the same amount. Okay? So even though the pieces are smaller, because you're having more of them, they add up to the same. So 1/2 is the same as 2/4 is the same as 4/8. Because whatever we do to the top, we do to the bottom. Okay? So if I was to multiply this by 10, and this by 10, 40 out of 80 is the same as 1/2. They are equivalent. Even though they look different, even though this looks so much bigger, it's the same. So imagine a pizza and you cut into 80 slices. The slices are going to be tiny. So if you had 40 of them, it would add up to half of the pizza. Okay, so same here. So 1/3 would be the same as 2/6. Would be the same as 3/9, because whatever we do to the top, we do to the bottom. So to get to 2/6, we multiply top and bottom by 2. To get to 3/9, we multiply top and bottom by 3. They end up being the same. So this is very similar as well. Okay, so to get from one fraction to an equivalent fraction, we multiply or divide the top and bottom by the same number. So this is all about knowing your multiplication, being able to see what numbers go into top and bottom. Okay. So what do these sketches show? So this one would be 1/2, this one would be 2/4, and this one would be 3/6. They're all equivalent. They're all the same, as you can see from the diagram. So 1/5 would be the same as 2/10. If we divide top and bottom by 2, we'd end up back at 1/5. Okay, 1, 2, 3, 3/4 is the same as 6/8, which is the same as 1, 2, 3, 4, 5, 6, 7, 8, 9, twelfths. And 1, 2, 3 over 5 is the same as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 over 13, 14, 15, 16, 17, 18, 19, 20. Because top and bottom have been multiplied by 4. Okay, so have a look at these ones. Okay, I won't go through all of them. Okay, I'm just going to pick some at random. But if you would like to, pause the video and just have a go at these equivalent fractions. So nice and straightforward for number 1. Sorry, we look at what number has been multiplied or used here to get from there to there. 2 to 8, we need to multiply by 4. Therefore, the top needs to be multiplied by 4. Okay, number 2, the bottom has been multiplied by 4, so the top needs to be multiplied by 4, and we get to 8. Number 3, 4 has been multiplied by 3 in this instance, so the top, 3. So whatever we do to the top, we do to the bottom. So here's been multiplied by 2, so the top gets multiplied by 2 to get to 6. Okay, and in the same way, here, 12 has been divided by 6, so the top gets divided by 6. So 6 over 12, sorry, is the same as 1 over 2. Okay, I've looked at 10. How did I get from 15 to 3? Well, I divided by 5, so the top gets divided by 5, I end up at 1. 18 has been divided by 6, so the top gets divided by 6, so 2/3. Okay. Questions may ask you to simplify your answer. Okay, and this is what you would do. Okay, if you worked out an answer as a fraction, sometimes it'll say give your answers in the simplest form. This is what you would do, otherwise you'd end up losing a mark. So this is divided by 2, so that's divided by 2, and we get there. Okay, so 3/5 would be the same as 6/10. Top and bottom times by 2. This has been divided by 4, so that gets divided by 4, which is 5. And a half has been times by 4, so the top gets times by 4. Okay, so like I said, simplest form. So simplest form is when you cannot no longer divide top and bottom by any more numbers that are the same. Okay, so if the top and bottom of the fraction are multiples of the same number, then the fraction can be simplified using equivalent fractions. A fraction in its simplest form is when the numbers on the top and bottom are as small as possible and they can't be divided by the same number anymore. So we've got 10/5 and they want it in the simplest form. Well, we can see that 5 goes into top and bottom. So we divide top and bottom by 5 and we end up at 2/3. Now, does anything else go into 2 and 3? Not that I know of. So we stop. We can't go any further. This will gain you marks in the exam. So 36 over 144. Okay, what I wouldn't do is, in this example they've gone straight for 12, but I don't know about you, but 12 doesn't strike me as the first number that I would use here. I'm going to try and make it more simple for myself. I'm not going to sit here worrying about the biggest number, trying to find it. So if they're both even, I would divide by 2. So they're both even. So 18 over 22 and 50 would be 72. Yeah, so 72 would be half of that. So now I'm going to divide again by 2, which is 9 and 36. And then both now are divisible by 9. So 1 over 4. So I've took a slightly different way than this, but we've still got to the same simplest form. So make it easy for yourself. You don't need to try and divide top and bottom by 15s or 12s. If they're both even, divide by 2, make it easier for yourself. It may take a few more steps, but it's going to be quicker because you're not worrying about a big number to divide by. So some examples here. Again, I'm not going to go through all of them. If you'd like to pause them and have a go, that's entirely up to you. So, first one, 20 over 50. If they end in zeros, straight away they're divisible by 10. So we can end up at 2 over 5. Get rid of those zeros, we've divided by 10. 2 and 5, nothing goes into both of them, they're the same, so we stop. 12 over 16, again divisible by 2, so 6 over 8. Oh, still divisible by 2, 3 over 4. So it took me 2 steps, but it's not an issue because it was easy to do. Here we've got 9 and 7, or 27, not divisible by 2, not divisible by 10, not divisible by 5. So process of elimination, 3. So we do 3 over 9. And again, divisible by 3 again, so 1 over 3. Okay, if you want to know if a number is divisible by 3, you add the 2 digits together. So 2 plus 7 equals 9. If this number, if the answer is in the 3 times table, it's divisible by 3. So that's just a tip for you. Again, both are divisible by 2, so 6 over 15. Not divisible by 2 now. 1 plus 5 is 6, which is in the 3 times table, so it's divisible by 3. So 2 over 5. Here, divisible by 10, so 8 over 10. And again, divisible by 2, so 4 over 5. And again, divisible by 2, so 16 over 24. Divisible by 2 again. Divisible by 2 again. Divisible by 2 again. So it took a few steps, but it wasn't difficult to do. Okay, so again, have a go at these ones. Right, so now we're moving on to finding a fraction of something. So it may be a sale where it's a third off. It might be 20%, 25, a quarter extra and things like that. So you might have a bag of crisps where you get a quarter extra and you want to work out how much more you're getting. So to find a fraction of something, okay, straightforward, divide by the bottom. So divide by the bottom number, by the denominator, and then multiply by the top. Multiply by the numerator. So in this instance, we've got 1 over 32. So whatever number that we're trying to work out, so in this instance, 14,656, we divide by 32, by the bottom number, which is 458, and we times by the top number. In this instance, it's 1, so it doesn't really change. So 1/32 of 14,656 is 458. Survey asks 32,820 people whether they are satisfied with their job. 7/12 said no. How many people said no? So we divide by 12. So 32,820 divide by 12. Then we multiply by 7, which is the top number. So divide by the bottom times by the top. So 19,145 people said no. So let's apply this to some exam questions. So what is a fifth of £100? So £100 divided by the bottom number, which is 5, which gives us 20, times by the top, which is 1, leaves us at 20. What is 2/10 of £100? So £100 divided by 10 is 10, times by 2 is 20. So we've ended up at the same answer, but that's because this and this are equivalent fractions. So a quarter of 448. So we do 448. We divide it by 4. So 448 divided by 4 gives us 112. We times it by the top number, which is 1. I'm not going to change anything. It's 112. So 3/4 of 848. So divide that by 4. So 848 divided by 4 gives us 212. Times that by 3, which is the top number, gives us 636 as our answer. So a jacket costs £45 and it's reduced by a third. If it's written in letters, I would just go a third just to help me out. So how much is saved? So 45 divided by 3 is £15. Times by 1, which is the numerator, is 1. So what is the new price? So the jacket costs 45, we're saving 15, so the new price is 30. 70 people take a driving test, a fifth of them fail. How many people fail? So again, a fifth is just 1 over 5. So 70 divided by 5 gives us 14, times by 1 is still 14. So how many people pass? So 70 people took their driving test, take away the 14 that failed, is 56 people that passed. Okay, 4 colleagues share a prize of £340 equally between them. How much do they each get? So if it's 4 colleagues, they're going to get 1 out of 4. So 340 divided by the bottom number, which is 4, which is 85, times by the top number, not going to change it, so they all end up with 85. So a sixth of adults in a town did not vote. There are 21,000 adults. How many did not vote? So 21,000 divided by the bottom number, which is 6. So 21,000 divided by 6 is 3,500. How many people did vote? So 21,000 take away 3,500. Again, I didn't times this by 1 because it doesn't do anything. So 21,000 take away 3,500 is 17,500 people did vote. Okay, so here's just a check of your knowledge. So if you want to pause it and have a go through these and see how well you did. Okay, adding and subtracting fractions. So when we think about adding and subtracting, okay, probably the easiest mathematical thing to do. Adding, nice and easy. Subtracting, nice and easy. When it comes to fractions, I'd say it's actually one of the more complicated things to do. You can only add fractions and subtract fractions where the denominator, the bottom number, is the same. Okay, so in this instance, 1/8 add 4/8 is 5/8. We only add the top number, we only add the numerator. The bottom number, the denominator, needs to be the same and stays the same. And then when we're subtracting, we just subtract the top number, the bottom number stays the same. So, obviously, not all fractions are the same. So, in this instance, we've got a tenth add 3/5. So what we would need to do is turn this number to an equivalent fraction, and we can see that if we multiply top and bottom here by 2, we end up at 6/10. Okay, so 3/5 is the same as 6/10. So now the numerator, or the denominator, is the same. So we can add. So 1 add 6 is 7, and we end up at 7/10. Okay, so sometimes it's as easy as just changing the one fraction. Okay, multiplying it by the same number top and bottom to get an equivalent fraction and doing it that way. Sometimes it's not as straightforward. So 1/5 and 2/7. There's nothing I can do to get this to a 7, and there's nothing I can do to get this to a 5th. So what we need to do, the easiest way to do it, is multiply the bottom two numbers together. So 3 times 5, or not 3 times 5, 5 times 7 is 35. So the first fraction, I multiply by the bottom number by 7, so I do the same to the top. So 1 times 7 is 7. So 1/5 has been multiplied top and bottom by 7 to get 7 over 35. The second fraction, the 7, has been multiplied by 5 to get to 35. So the top number needs to be multiplied by 5 as well. So we end up with 10 over 35. So 7 over 35 and 10 over 35. Okay, and then we just add the top numbers together and end up at 17 over 35. Okay, so we'll go through a few more examples. So work out 3/10 and 2/5. So 3 over 10 add 2 over 5. So what I can see straight away is this number can turn into 10. So 3/10 and then add 4 over 10. So multiply top and bottom by 2 to get an equivalent fraction. So now end up with 7 over 10. Okay. 4/9 add 1/5. So now there's nothing I can do to get these together. So what I need to do is multiply these two together. So 9 times 5 is 45. So two bottom numbers are going to be 45. First fraction, the 9, I multiplied by 5. Okay, so 9 times 5 is 45. So the top number I need to multiply by 5. So 4 times 5 is 20. The second one, so the bottom number here, I'll multiply by the 9. So the top number I'll do by 9 as well. So 1 times 9 is 9. So altogether, it's 29 over 45. Okay? Right, so if you want to have a pause at this and have a go, and we'll go through the answers in a second. So have a pause, go through if you like. Okay, so 1 over 10 plus 3 over 5. So straight away, the second fraction can be doubled to 6 over 10. So that's just going to be 7 over 10. 1 over 5 plus 3 over 4. So the bottom two numbers, if I multiply together, are going to be 20. This first fraction was multiplied by 4, so the top number multiplied by 4. And the top number here is going to be multiplied by 5, which is 15. So that's going to equal 19 over 20. And 4 over 9 plus 1 over 5. Both are going to be over 45. This top one's going to be 20, this top one's going to be 9. So that's 29 over 45. Okay, hopefully that made sense. Okay, let's apply this to some exam style questions. So a running track is 1 kilometre long. Mike jogs for a sixth and runs for 2/3. Has Mike completed the full track? So a sixth and 2/3. So if we add this together, we should be able to know if he's completed the full track. So if we can double this first one, so 1 over 6, add 4 over 6. So all I've done is multiply top and bottom by 2, which is going to be 5 over 6. So has he completed the full track? Well, if he'd have completed the full track, it would be 6 over 6. Because when the top number and the bottom number are the same, it equals 1, which is a whole. So the answer is no, he's not completed the full track. Right, 3/4 of a office stationery budget is spent on paper, a sixth on envelopes, the remainder on other items. What fraction is spent on other items? So we can't just change these, so what I would do is multiply them together. So 24 is going to be our bottom number. The first fraction was multiplied by 6, so the top number is multiplied by 6, so 3 times 6 is 18. The second fraction was multiplied by 4, so the top number is multiplied by 4, which is 22 over 24. So what is the remainder of the other items? So if it's a whole, it's 24 over 24. Take away 22 over 24, which is going to leave us 2 over 24. If it did say to simplify your answer, top and bottom is divisible by 2, which would be 1 over 12. So a 1/12 of the budget is spent on other items. George, Ahmed and Sam share a pizza. George eats a half, Sam eats a third. No, Ahmed eats a third and Sam eats the rest. How much does Sam eat? So we add these together. So multiply the bottoms together, 6 and 6. This one was multiplied by 3. And this one was multiplied by 2, which is going to be 5 over 6. The whole of the pizza is going to be 6 out of 6. Take away 5 over 6, we leave a sixth. So Sam got a little bit short-changed there. George ate half and he only gets a sixth. Poor Sam. Right, a worker spends a quarter of their wages on rent, so a quarter on rent, a third on clothes, and a sixth on food. What is the total fraction that she spends? So here we've got 3. Okay, so we need to add all these together. So straight away I would look for a number that all 3 of these go into. We could multiply them all together, but the numbers might end up a bit big. So what number does 4, 3 and 6 go into? Well, the answer is 12. They all can go into 12. So we're going to turn them into equivalents with the 12ths. So what did I do to 4 to get it to 12? Well, I multiplied by 3. So the top number's multiplied by 3. The 12th I multiplied by, or the third, sorry, I multiplied by 4. so top number gets multiplied by 4. And the 6th are multiplied by 2, so the top number gets multiplied by 2. And if we add all these together, we end up with 9 twelfths. So what fraction does she spend? 9 twelfths. What fraction does she have left? So total is going to be 12 over 12. Take away 9 over 12 is 3 twelfths. Can we simplify this answer? Yes. 3 goes into top and bottom. So it'll be 1 over 4. So this worker has a quarter of her wages left after all of the bills have come out. Okay, last one in this one. So in a bag there are red, green and purple counters. 3/8 are red and a 1/6 are green. What fraction are purple? So multiply these together. 48, 48. This first one got multiplied by the 6, so the top gets multiplied by 6, which is 18, and this one's getting multiplied by 8. So we add these together, it's going to be 26 over 48. So the total would be 48 over 48. Take away 26 over 48. So if we did 48 take away 26, it's going to leave us with 22 over 48. If it asks us to simplify, we could divide top and bottom by 2, which would be 11 over 24. If it says simplify, simplify because you'll lose a mark. If it doesn't say simplify, save yourself some time. Okay, improper fractions to mixed numbers. So, improper fractions are what you call your top heavy ones. So they're the ones that the top number, the numerator, is bigger than the denominator. So in this instance, it might be like 9 quarters, 2 over 1, 4 over 3. Okay, so they're your improper fractions. A mixed number is when you have a whole number and a fraction, it's mixed. You've got 1, which is your whole number, and a 5th, which is your fraction. So, to convert from a fraction to a mixed number, you need to divide the top number by the bottom number. You should do this without a calculator and you end up with a remainder. Okay? So, in this instance, we've got 25 over 8. So, 25 eighths. 25 divided by 8 is 3, which is 24, and there's 1 left over. So in this instance, you can have 3 wholes, and your remainder goes on top of the fraction. So whatever the remainder is goes on top of whatever the denominator is. So we'll go over that in a few examples. So 5 halves, sorry. So we do the top number divided by the bottom number. So 5 divided by 2 is 2, and there's 1 left over. So that goes on the top of the fraction. So 2.5. So they're the same. So 5 halves is the same as 2.5. 21 fifths. So 21 divided by 5 is 4. And there's 1 left over. So that goes on the top of our new fraction. So 21 over 5 is the same as 4 and a fifth. And the last one, 10 over 7. So 10 divided by 7 is 1. In this instance, there's 3 left over. So that's going to go on top. So 10 divided by 7 is 1, because that would be 7. And to get from 7 to 10, we'd have 3 remainders, which would go on the top. And then we can go the other way. So from a mixed number to an improper fraction. So what we would do here, so we've got 1 1/4, and we've got 2 3/5. Okay, so these are our mixed numbers. To get to the fraction that's equal, what we would do is multiply our whole number by the denominator. So 4 times 12, which is 48. And then we would add that to the numerator that we have. So that would equal 55 over 12. So we multiply the whole number by the denominator and then add it to the numerator. Again, we'll go through. So 1 2/3. So what we do is 1 times 3, which is 3, and then add it. So we've done the 1 times the denominator, and then we add that 3 to the 2, which is 5. So it's going to be 5 over 3. Okay, so we multiply the whole number by the bottom number and then add it to the top. So 2 times 2 is 4. Add the 1 is 5 over 2. 5 times 5 is 25. Add it to the top is 28 over 5. Okay, so adding mixed numbers. So 2 ways of doing it. So we can convert them all to mixed improper fractions, do it that way, or we can just do it this way. So what we could do is separate. So when it comes to the adding, separate it. So we've got the 1 add 1, which is 2. You can keep that to the side. Then we've got a quarter add a half. So we do what we've done before. Okay, so we've got a quarter add 2 quarters. So I've just multiplied top and bottom, which equals 3 quarters. So we've got 2 and 3 quarters. Okay, nice and straightforward. Gets a bit trickier when we have something like this. So 5 add 2 is 7. We'll keep that to the side. Then we've got a half add 5 eighths. So we can see that this half can be converted to eighths. So that's going to be 4 eighths add 5 eighths, which is 9 eighths. What we're not going to do is say that the answer is 7 and 9 eighths. That would be wrong, because now we've got a mixed improper fraction which doesn't make sense. So 9 eighths is an improper fraction. The top number is bigger than the bottom. So 9 divided by 8 is 1, remainder 1. So now we've got 1 eighth. Remember the 7 from before? We just add that on. So it's going to be eighth. 8 and an eighth. Okay, so we just take it logically step by step. We've added these together. We've ended up with an improper fraction. So we turn that to a mixed, and now we can add them together. Okay, so 3 add 2 is 5. Push that to the side. 4 sevenths add a half. So we can't convert easily here. So if we put them over 14, which is 2 times 7. The first one we need to multiply by 2, which is 8. And the second one we need to multiply by 7, which is 7. So that's going to equal 15 over 14. Problem, improper fraction. 15 divided by 14 is 1, remainder 1. So that's 1 and 1/14. Add it to the 5 whole that we had before. So that's 6 and 1/14. Okay, so 3 add 1 is 4. Let's keep that to the side. A half, add 5 sixths. Again, we can multiply this first one by 3. So that's going to be 3 over 6, add 5 over 6 is 8 over 6. Problem, it's an improper fraction. So 8 divided by 6 is 1 and 2 sixths. Add that to what we've got here. It's just going to be 5 and 2 sixths as our answer. Okay, so what is 1 and 2/3 add 2 and 5 sixths? So 1 add 2 is 3. Let's push that to the side. 2 over 3 add 5 over 6. So what would we do here? We could multiply the bottoms together, but I can see that this first one we can turn into sixths. So it's going to be 4 over 6 add 5 over 6 equals 9 over 6. Improper fraction, so we need to convert to a mixed. 9 divided by 6 is 1, remainder 3. That's 3 sixths. So add that to our whole number, so 4 and 3 sixths. Or, if you want to be really fancy, you can simplify that to 4.5, because 3 sixths is a half. Okay, Jasper's going on holiday. The airline says he can take a maximum baggage of 22 kilograms. His main suitcase weighs that. His carry-on bag weighs that. He also has another small bag that weighs that. Will he be allowed to take all of his baggage on the plane? Right, let's get into it. So 18. and 3/4, add 2 and 3/8, and then add 4/5. Right, let's get rid of these whole numbers. So 18 add 2 is 20. So keep that over there. So if I get my rubber, get rid of them. Gone and gone. Okay, so 4 add 8 add 5. What number do they all go into? So my first instinct is 40. So let's put them all over 40. So 3/4, I'll multiply the bottom by 10, so I do the same to the top. The 8 I've multiplied by 5, so I do the same to the top. And this one I've multiplied by 8, so I do the same to the top. So 4 8s are 32. Then we add all these together. So 30, add 15, add 32 is 77 over 40. So 77 divided by 40 is 1, and 37 over 40. Add that to there, so now we've got 21 and 37 over 40. Not add. So 21 and 37 over 40 kilograms. So will he be allowed? Yes, just about. He literally has 3/40ths of a kilogram to spare. So yeah, Jasper's done good, just about. Okay, during a 3-day holiday, 1.5 centimetres of rainfall on the first day, 1 3/4 on the second day, and 3 3/4 on the third day. How much altogether? So 1 add 2 add 3, so that's 5. So let's get rid of those whole numbers. Gone, gone, gone. So nice and easy. These ones are in quarters, this one's in a half. So multiply top and bottom by 2. So 2/4, add 3/4. Add 3/4 is going to be 8/4. Top and bottom, we divide the top by the bottom, which is going to be 2. So how much rainfall altogether? 7, because I've added that on. So there's no actual fraction in the answer now. It's just 7. Right, so I've got a couple of questions here. I'm not going to go through them, but you can pause and have a go at them yourself if you would like to. So this is the first one. This is the second one. And this is the third one. Okay, now we're going to come on to subtracting mixed numbers. Okay, so this isn't as straightforward as the adding. This time we do need to convert to improper fractions in order for us to be able to do it. We can't just separate the whole numbers and the fractions now. We need to do it all together. So 2 2/3 add 1 and take away 1 3/8. So 2 times 4, which is 8, add the 3, so that's going to be 11 over 4. 1 times 8 is 8, add 3 is 11, so that's going to be 11 over 8. So now we've got two improper fractions, but they've got different denominators. So now we need to convert this first one. So top multiplied by 2 and the bottom multiplied by 2 to get the eighths, which will be 22 over 8. Take away 11 over 8, which is going to be 11 over 8. And then we can change it back to a mixed number. So 11 divided by 8 is 1, remainder 3, so 3 over 8. So go through them. So again, we're not just going to separate it. So 4 times 3 is 12, add the 1 is 13 over 3. Take away 3 times 9 is 27. Add the 4, which is 31 ninths. Okay, so we need to get the bottom number the same. So 3 times by 3 is 9. So it's going to be 39 over 9, take away 31 over 9. So all I've done with this first fraction is multiply top and bottom by 3. So top and bottom multiplied by 3 gets us the equivalent fraction with ninths. So now we can just take these away, which is going to leave us with 8 over 9. Okay, that's all we need to do. Okay, we're done. Okay, this one, so 5 times 5 is 25, add the 1 is 26 over 5. Take away 3 times 3 is 9, so that's going to be 11 over 3. Okay, so what do we do here? We need to multiply the bottoms together to get 15ths. 26 multiplied by 3 gets us 78. 11 times by 5 gives us 55. Because this fraction was multiplied by 5, this fraction was multiplied by 3. So 78, take away 55, leaves us with 23 over 15. Improper fraction. So 23 divided by 15 is 1 with 8 left over. That's 1 and 8/15. Okay, and our last one. So again, we need to turn it into an improper fraction. So 4 times 4 is 16. Add the 1 is 17 over 4. Take away 2 times 3 is 6. That's 7 over 3. So we multiply the bottoms together to get 12 and 12. Okay, so the first one we multiply by 3. So 17 times by 3. 17 times by 3 is 51. 7 times by 4 is 28, so 51, take away 28, leaves us with 23 over 12. Okay, so how many 12s fit into 23? So that's 1, remainder 11. So 1 and 11 twelfths is the answer. Hopefully you found that useful, hopefully it made sense. So just think to yourself, what did you find useful? What could you learn? What would you like to learn more about? Is there anything that I can go through in a bit more detail? And yeah, so if you want to, have a go at the questions that we went through in the session. Log on to SharePoint, download the associated worksheet, send them to me to get them marked. That's absolutely fine. Hopefully it made sense, guys, and thank you for listening.